Hello everyone, our paper is entitled Open World Active Learning with Stacking Ensemble for Self-Driving Cars. The environments in which autonomous cars act are high risky, dynamic and full of uncertainty, demanding a continuous update of the sensorial information and knowledge bases. Thus, at training time, it's not possible to know the set of objects that the agent will face. Therefore, the training phase needs to be continuous acts along the entire life of the agent. This problem is formally given by a set of training data with n classes, where the goal is to create a classifier that can classify each image to one of the n known classes or as an unknown that is not belonging to the training set. In case of being classified as an unknown, the next goal is to ask the oracle to label the image and use it in the next training iteration. To solve our problem, an open world AI approach is more suited because it allows dealing with a considerably large number of objects whose classes are not known previously. For this, we attempted to create a model for autonomous cars that these can learn about the new classes and not rejecting them, allowing the new identification of objects from unknown classes while still correctly recognizing all objects from known classes. To train our model, we used a dataset made of two different files: a colored image with all the elements present in the range of view of the car, and a JSON file containing all the different labels of the elements in the picture, as well as the pixel positions of the object borders. The goal with these two files is to remove from the range of view of the autonomous car the objects described in the JSON file. These can be cars, pedestrians, sidewalks, and so on. Our work consists of n models, being these convolutional neural networks, each with a specific part of the dataset and with their own specific labels. Then, we train each model separately. Our next step was to stack the trained models, obtaining a stacked committee, and chain it with the logistic regression model. Lastly, we verify the outputs of the stacked committee and we label the entries when certainty is less than a certain value alpha with the help of the oracle. As most of our initial work was based on a paper that deals with text instead of images, our CNNs had to be adapted to our problem, and for this we tried three different convolutional neural networks. The first structure A consists of two two-dimensional convolutional layers, followed by a 4x4 max pooling layer, a fully connected layer, and an adaptive output layer for dealing with n+1 labels. The second structure B is similar to the previous one, but with a smaller max pooling layer and a dropout layer preventing overfitting by 20%. The last one has three two-dimensional convolutional layers, with a 2x2 max pooling layer between the second and the third convolutional layer, and a 4x4 max pooling layer after the third convolutional layer. From this point on, it's equal to the second structure. For this work, we use the simple stacking ensemble strategy, where all the models have the same contribution to the final output, opting by a separate stacking model utilizing logistic regression to take in the values among the different models, selecting the best label representing the picture with a degree of certainty to achieve the best results. Although the stacking ensemble provides us with good results, we cannot take for granted that the label provided is the correct one, since committee members may come across new objects. To this end, we use the degree of certainty to help us identify misclassified images. Some final tweaks had to be done in order to complete our experimental setup. We had to define the number of elements in the committee, they were between 2, 3 and 5, in order to understand the power and importance that each unit could provide. We also had to define how many labels were in the system and known previously. We considered 6 labels in the system, being these cars, pedestrians, buildings, vegetation, traffic signs and traffic lights, and since cars and pedestrians are the most important entities while driving, because one of the primary goals of driving besides taking someone from point A to point B is to avoid hurting others and damaging the car, we included them in the known label sets from the beginning. One of the key points we took while developing our work was that when we look at some runs based on different datasets in the closed set of labels, considering the results provided by the committees with different sizes, there is always an increase of accuracy when passing to the stacked network. We also verify that our committee has the best performance when it's working with 5 elements. Another key point taken was, whenever a new unknown variable was added, the accuracies of the different elements of the committee and the stacked network drops drastically. This may be due to the complexity of the object, where a tree is visually more complex than a traffic sign, for example, due to the different branches and leaves that makes it up. Overall, our third convolutional neural network provided the best and most consistent results for these experiments. One of the problems we encountered was in our CNNs, that even though they provided good results, we were not able to achieve optimal values. A second problem was found when we attempted to introduce 4 or more unknown labels to our network. Here the models went from 40% accuracy to values between 2 and 8%. We also discovered that some images had complex elements that were hard to label even to the human eye due to the obstruction of other objects. This could also be a vector in the unbalanced training and testing. In the future, in order to reach better performances, we plan to choose a different variant of stacking ensemble, in which, rather than being ruled by a separate stacking model, which only makes use of logistic regression to get the best results of the agglomerate of models, we could try to make use of an integrated stacking model which inserts the several models in the committee and embeds them into a larger multi-headed neural network that could be trained to better combine the different predictions.